Hello physical science folks, hopefully this help video will help you with the first 6 questions, scenario 1 to 6. So here we have Pedro and a wolf running. Now Pedro has a mass of 80 and the wolf has a mass of 40, so Pedro is twice as massive. But if you look at the velocity of the wolf versus Pedro, the wolf is 3 times as fast. So who's going to have more kinetic energy? Okay. But please note that whenever you plug in mass, you just simply have that number. But when you plug in that velocity, it is square. Square means that a number is multiplied by itself. So for example, if Mr. Wu runs 5 meters per second, I have, say, pretend 100 units of kinetic energy. But when I run 10 meters per second, I have 4 times the kinetic energy, because why? When I'm going twice as fast in the velocity, pretend this is a 2 instead of a 1, 2 times 2 is equal to 4. And the same is true even if it's a different number. So pretend I run 3 miles per hour, okay? 3 times 3 is 9. But when I double my speed to, like, say, 6 miles per hour, 6 times 6 now is 36. So when I go from 3 miles per hour to 6, I double my speed. My kinetic energy becomes 4 times as great. However, when I double my mass, that is not square. It's not multiplied by anything to make it grow up. Go up exponentially. So it will be the same straight increase. So if I double the mass, I'll have double the kinetic energy. If I triple the mass, I have the triple kinetic energy. So the same question is once again here. If I'm doubling the velocity, why is my damage 4 times as much? So think about this part right here, especially that number. What does that mean? Here, okay, same question again. If I can double the mass or the velocity of an arrow, which one does more damage? So let me ask you, if someone pick up a small rock that weighs 10 grams and they throw it at you at, say, 50 miles per hour, it's going to leave a bruise, but it's not going to kill you or cause major damage if it hits your body, okay? Now, if they double the mass and it weighs 20 grams and they hit you, that will hurt quite a bit more. Leave a bigger bruise, but it's probably not going to kill you. Now, what if someone picks up a rock that's just 10 grams like the first rock, but now they throw it twice as fast? Now remember, twice as fast means 2 times 2 because of the square. You're going to get a lot more damage. So once again, which one would you have more kinetic energy by changing? Is it doubling the mass or doubling the velocity? Okay? That's why in the medieval age, they always try to make the ball high tension so they can increase the velocity. So potential energy is stored energy. And kinetic energy is energy in motion. So when we talk about potential energy, think of it like a rubber band being stretched out or like a flexible item being bent. The more you change its location from its original position, the more energy is stored into it. Or the more you stretch out a rubber band, the more energy is stored. So pretend we have a rubber band connected from here up to here and another rubber band being connected from here up to here. So when I move the box up, I'm stretching them out to the same length. So with that, explain why they both have the same potential energy. Here we have 2 yellow balls that's the same mass and a blue ball that's roughly about 1/3 the mass of the yellow ball. Now why does ball C have the most energy? So imagine this one is 2 thick rubber band. One is being stretched out from here to here, and one is the same thick rubber band being stretched out from here to here. The reason why I say thick is because the ball is bigger. Now I have a thinner rubber band being stretched out from here to here. Which rubber band is going to snap the hardest? The thick one being stretched a little bit, the thin one being stretched a lot, or the thick one being stretched a lot? And with that, you know that there's only 2 things that affects the gravitational potential energy of the item. One is the mass, like the thickness of the rubber band that I said is invisible, aka gravitational pull. And then the second thing is the height. The taller the height, the more that rubber band is being stretched out, okay? So the mass is like, this is a skinny rubber band, low mass, and this is a thick rubber band. And then the height is how far you stretch that rubber band out. So with that, looking at this, the ground is where the rubber band is. Where is this going to have the highest potential energy? Being stretched from here to here, from here to here, or from here to here. So the higher the roller coaster is, the more that invisible gravitational potential energy rubber band is being stretched out. So with that, think about that and answer the question. Hopefully that helps. If it doesn't, go ahead and ask your teacher for more clarification during the class or during the